This is question number 17. A solid disk of mass m and radius r is freely rotating horizontally in a counterclockwise direction with angular speed omega about a vertical axis through its center with negligible friction. The rotational inertia of the disk is mr squared divided by 2. A second identical disk is at rest and suspended above the first disk with the centers of the two disks aligned, as shown in the figure above. There is no contact between the disks. The second disk is dropped onto the first disk, and after a short time, they rotate counterclockwise with the same angular speed omega final. So the question is, which of the following properties of the two-disk system must be conserved between the time the second disk is dropped on the first disk and the time that the two disks begin rotating with the same speed? So the options are kinetic energy only, angular momentum only, both kinetic energy and angular momentum, neither kinetic energy nor angular momentum, or it cannot be determined without knowing the nature of the forces between the two disks. So, in order to get the answer to this, we have to look at what happened when they collided. When the second disk was dropped onto the first disk, it did not bounce. The kinetic energy was not conserved. This is because it telling us that it was an inelastic collision. So we know that the kinetic energy was not conserved, meaning that C is not correct, because that C states that both kinetic energy and angular momentum are conserved, but we know that kinetic energy is not conserved. And we know that A is incorrect, because A says that kinetic energy only is conserved, which is incorrect. So what we have left is B, angular momentum only, D, neither kinetic nor angular momentum, or E, it cannot be determined. So since we aren't adding, since we are not applying any since we are not adding any energy to the system or taking any energy out of the system, our angular momentum must always be conserved. So we know that our angular momentum is going to be conserved. So that means that D can't be correct, because D says that neither kinetic energy nor angular momentum is conserved, and we know that angular momentum is conserved because there's no energy lost or gained in the system. And E says that it cannot be determined without knowing the nature of the forces between the two disks. We don't need to know the nature of the forces between the two disks to determine that the angular momentum has to be conserved, because momentum is always conserved when energy is not lost from a system or gained in a system. So it's not E. So the answer is B. Angular momentum only is conserved, because the kinetic energy is not conserved because it was an inelastic collision in which the first disk did not bounce or immediately start turning. It just fell and stuck on the first disk. And we know that the angular momentum is conserved because there is no energy applied or taken taken from the system.